Welcome. Today we're going to be working on solving systems by substitution, and this is day number 2. Our content objective is students will be able to solve a system of 2 equations by using the substitution method. Language objective is students will be able to discuss ways of checking the solution that you derived is truly a solution or not. Why am I learning this? Well, it's important for real-world problems like finding the best value among high-speed internet providers. So first, let's go over some background knowledge. We did work with substitution yesterday with shapes. Here we went ahead and understood that a circle and a square is 10, so we swapped out a circle and a square with a 10, and we solved it algebraically. Here we subtract 10 from both sides, leaving us with a circle equals 8. From there, we went ahead and plugged in our values for circles, which we claimed to be 8. 8 plus a square equals 10. What should the value of a square be? We got that the answer is 2. So after that, we just double checked our work. 8 plus 8 is 16 plus 2 is 18. So that works out. 8 plus 2 is 10. 10 does equal 10. That also checks out. Okay, so now for today, what you're going to notice is we're not going to be using shapes anymore. We're going to actually use variables. So here it says x plus x plus x equals y, and x plus y equals 24. Well, first of all, I know that a y equals 3 x's. So what I'm going to do is I'm going to take these 3 x's and replace this y right here, since I do know that y equals 3 x's. So I'm going to go ahead and substitute that in. So now I'm left with x plus x plus x plus x. So if you're wondering, this is the new set that I just placed inside, equals 24. Well, now I have a total of 1, 2, 3, 4 x's, which equals 24. So here, since this does mean 4 times x, I'm going to go ahead and divide both sides by 4, and I'm left with x equals 6. Well, now that I know that x equals 6, what I'm going to do is go ahead and substitute it into this first equation here. I know that 3x equals y. Why am I using this one? Because I'm interested in figuring out what the value of y is. So I'm going to go ahead and substitute in 6 for x. And I'm going to get 3 times 6 is y, so therefore 18 equals y. Now that I know both values, I can go ahead and say that the solution is 6, 18. So notice here I'm actually able to write it as an ordered pair because solutions are written as y, x. Yesterday I was unable to do this because they were shapes, and with shapes you don't know which comes first. But since in this particular problem they gave us x and y values, I can definitely use that. Now, real quick, you know that I like for you to check your answer. So here, x is equal 6, so you would have gotten 6 plus 6 plus 6 equals 18. Is this true? Yes, it is. This one, x is 6 plus y, which is 18, is supposed to equal 24. 6 plus 8 is 24. Does 24 equal 24? Check. Okay, so now let's take a look at one more example. Here, for problem number 2, y equals x. So, what does that mean? Well, there's 2 ways you can do this. I'm going to go ahead and understand that y equals x. So I'm going to go ahead and replace this y with an x because y equals x. So now I have the x plus x. I went ahead and replaced this one y with an x, leaving me with 3x equals 15. This is 3 times x, so the inverse would be to divide both sides by 3, leaving me with x equals 5. Which is great. However, I still need to know what the value of y is. So I have 2 options. I can choose the first or the second. I am going to choose to plug it into the first equation just because y is already set up to be solved for, since it's y equals. So I'm going to go ahead and put y equals. I'm going to replace this x with the value that I just got, which is 5. So here I know that the y is 5. So now that I know both, I can write it as an ordered pair as x comma y, and I would say that solution is 5 comma 5. But again, just like yesterday, let's check our work. Y is here real quick, x is 5, y is 5. So here, does 5 equal 5? Check. Here, does 5 plus 5 plus 5 equal 15? It sure does. So I know that my answer is correct. Okay. So now what I would like you to do is go ahead and pause the video and try number 3 on your own. And again, make sure you check your work to see if it checks out. Okay, so let's see how we did. So first of all, I do recognize that a y equals 2x's. So what I could do in this second equation is I can go ahead and replace a y with 2x's. So now I'm left with x plus the 2x's that I just added equals 6. That leaves me with 3x equals 6. So here, this means 3 times x, so the inverse would be to divide both sides by 3, leaving me with x equals 2. Okay, so now that I know the value of an x, I'm not done yet. I can choose whichever equations I want here. I am just going to choose this first one for the main reason of y is already solved for. It's y equals something. So I'm going to go ahead and do that. Since y equals, there's 2x's, I put 2x. I'm going to go ahead and substitute in my value of x of 2 into this equation. And I'm going to be left with y equals 2 times 2, which is y equals 4. Now that I know both, I'm going to go ahead and write it as a solution as x comma y. So I'm going to say that the solution is 2 comma 4, where x is 2 and y is 4. So real quick, let's double check to see if the solution works. Y is 4. Does 4 equal 2 plus 2? It sure does. Second one, x, which is 2, plus y, which is 4. Does that equal 6? It certainly does. So again, hopefully you came to the conclusion that the solution is 2 comma 4. Okay, so now, what if I went ahead and translated this? Instead of using x's and y's, I translated into an equation such as, this can be rewritten as y equals 2x, since there's 2 x's, and this of course would just be x plus y equals 6. So now here's the traditional method of using substitution. First, it's very important to make sure that one of your equations is solved for a variable. So in this case, this equation here has a variable solved for its y equals, which is perfect, so I do have one. So what I'm going to do now is, because I know that y equals 2x, I'm going to go ahead and take this 2x and replace this y here, which leaves me now with x plus, instead of putting y, I'm going to replace it with a 2x. Here, make sure you use parentheses because it's going to be very important, equals 6. Now, x plus 2x, I'm going to combine like terms. Let's not forget, we combine like terms by circling the terms. So x plus 2x is going to give me 3x equals 6. Divide both sides by 3. And I'm going to be left with x equals 2. So notice this looks very familiar to something that we've done from the previous slide, because it's exactly the same thing. So now what we're going to do is go ahead and replace the x with a 2. So in this equation, I'm going to write y equals 2 instead of x. I'm going to put parentheses, and I'm going to put the value of x, which is a 2. So now I get that y equals 4. So here, I can go ahead and say that my solution is, since we write it as x comma y, I'm going to write it as 2 comma 4. But last but not least, we need to make sure we check our work to see if the solution really does work. Okay, so let's go ahead and check our work. Here, y equals a 4. So I'm going to put 4 equals 2 times x. X is a 2. So here, 4 equals 2 times 2, which is 4. This checks out. Let's check the other one here. X equals 2 plus y, which is a 4. It's supposed to equal 6. 2 plus 4 is 6. 6 does equal 6. So here I've checked both. This solution works for both equations. Therefore, I can confidently say that the solution is indeed 2, 4. Okay, so now let's look at some steps. When we're solving systems of an equation, number one, we always want to make sure that we solve for one of the variables. Okay, at least one. Number two, once we have that, we can go ahead and substitute the resulting expression to the other equation. So if we get x equals, y equals, we're going to go ahead and use that equation to substitute into the other. Third, you must solve the equation to get the value of the first variable. So you need to solve to figure out one of the variables. Once you've done that, you can go ahead and substitute that value into the original equation to solve for the other variable. And once you've done that, you're going to go ahead and write the solution as an ordered pair, x comma y, and most importantly, you're going to check. Because ideally, we are looking for a solution that works for both. So, in order to prove that it is a solution, it should work for both when we check it. Okay, so now let's go ahead and take a look at this next problem. We're going to go ahead and solve it the traditional way instead of swapping out x's and y's like we did in the first few slides. So most important thing is, again, you need to make sure at least one of the variables is solved for. Here, this equation works nicely because I know what a y equals. Okay, so what we're going to do is go ahead and replace y with x plus 5. So in this equation, I'm going to go ahead and replace y with x plus 5. So now that's going to leave me with 2x plus, here, when I'm substituting, you always want to use parentheses, I'm going to put x plus 5 equals 8. Now normally, okay, you want to distribute. There is a positive 1 here that's being distributed, so really it's still 2x plus x plus 5 equals 8. At this point, what you're going to do is go ahead and combine like terms. So 2x plus x is going to leave me with 3x plus 5 equals 8. Now you're going to go ahead and get rid of your constant by subtracting 5 from both sides, which is going to leave you with 3x equals 3. So here this does mean 3 times x, so the inverse would be to divide both sides by 3, leaving me with x equals 1. Which is great, however, we're not done. I'm going to go ahead and now take this value and plug it into x here. So now I'm going to be left with y equals, instead of x, I'm going to go ahead and put a 1 plus 5, which leaves me with y equals 1 plus 5, which is 6. So now that I have both, I'm going to go ahead and say that the solution is, first, x is 1, and that y is 6. Perfect. But we need to make sure that this solution is indeed the correct solution, so we need to check. Okay, so here, let's just go ahead and remind ourselves that an x is y, the x values are 1s and the y's are 6. So here, y equals 6 equals x, which is 1, plus 5. So here I'm left with 6 equals 1 plus 5, which is 6. So this one checks out. Now let's check the second one. Here we have 2 times x, x is a 1, plus y, which is a 6, equals 8. So here 2 times 1 is 2, plus 6 equals 8. 2 plus 6 is 8, so 8 does indeed equal 8. So since it both checks out, I can confidently say that the solution is indeed 1, 6. Okay, so now let's take a look at another equation. Again, I can't stress to you enough, you want to make sure that at least one of the equation has a variable that is solved for. So in this case, it's going to be our second equation. Why? Because we know the value of y. Y equals 2x minus x. So I'm going to go ahead and take this value here, 2 minus x, and replace it for the y. So here I'm going to go ahead and substitute in 2 minus x in for the y value. Now here you have to be very careful. Why? Because I'm going to, let me show you, I'm going to put x minus, I'm going to go to put parentheses and put the value in for y, which is 2 minus x equals 4. Now what's in front of this 1? Well, it's a negative 1. So I'm going to go ahead and distribute that, which will now give me x. Negative 1 times 2 is negative 2. Negative 1 times negative x is positive x equals 4. So here, the thing that you need to be most careful about is making sure you're distributing that negative. In the previous example, it was a positive number, so distributing a positive 1 really didn't change the values at all. But distributing a negative definitely does. So at this point, what I'm going to do is go ahead and combine like terms. I'm going to combine a positive x and another positive x. So if you want, you can mark this as a 1 so that you know that there are one of them. So altogether, you now have 2x minus 2 equals 4. You're going to go ahead and get rid of your constant first by adding 2 to both sides, leaving you with 2x equals 6. Now this does mean 2 times x, so the inverse would be to divide both sides by 2, leaving you with x equals 3. However, you're not done yet. You're going to go ahead and take this value and go ahead and plug it in to the x here, which now is going to leave me with y equals 2 minus, what's the value of x? X is 3. So now I'm left with y equals 2 minus 3, which is negative 1. So now that I have the value of both x's and y's, I can go ahead and make my solution. I'm going to say the solution is, first you're going to write down the x, which is in this case a 3, comma, you're going to go ahead and write the y value, which is a negative 1. But of course, we need to make sure we check our work to see if this is indeed a solution that works for both equations. So let's go ahead and check it out. Okay, so here let's just remind ourselves the x values is 3 and the y values are negative 1. So I'm going to go ahead and plug them in. Y is a negative 1, so here I have negative 1 equals 2 minus x, which is a 3, which is going to go ahead and simplify to negative 1 equals 2 minus 3, which is negative 1. So this checks out. So now I'm going to check the next one. Here the x value is a 3. We're going to subtract the y value, which is a negative 1. It's supposed to equal 4. So here I'm left with 3. A negative times a negative is a positive, so that's going to be plus 1 equals 4. 3 plus 1 is 4. 4 definitely equals 4. So again, I can confidently say that my solution is indeed 3 comma negative 1. Okay, so now what I'd like you to do is go ahead and pause the video and try number 6 on your own and see how well you do. Okay, so hopefully you check to see that at least one of the equations has a variable that's solved for, and you do recognize that this equation here has x solved for. So you're going to go ahead and take this value of negative 2y plus 5 and substitute it in for this x value here. So we're going to go ahead and substitute this in. So that's going to leave us with 2 times the quantity. Well, x is now going to be rewritten as negative 2y plus 5. We're still going to put plus 3y equals 7, just bringing that down. Now here you're going to distribute the 2 to both terms, which is going to leave us with negative 4y plus 10 plus 3y equals 7. At this step, you're going to go ahead and combine like terms, which is going to leave us with negative y plus 10 equals 7. First, you're going to get rid of your constant by subtracting 10 from both sides, leaving us with negative y equals negative 3. Now, here's where you need to be very careful. We still have a negative out front, so we do recognize that this is essentially a negative 1y. So since it's being multiplied, we're going to divide both sides by negative 1. Here the negatives cancel out, leaving us with just y equals 3. But now that we know the value of a y, we're not done. We're going to go ahead and take this value and plug it into our y here. So now we're going to be left with x equals negative 2 times the quantity, which is a 3. I'm going to replace that y with a 3, plus 5. Now I'm left with x equals 2 times 3 is negative 6 plus 5. That's going to give me x equals negative 1. So now that I know the value of both, okay, I can go ahead and say that the solution is, first we write x, so that's going to be negative 1, comma, and then we're going to write our y value, which is 3. And most importantly, like it says down here, we're going to make sure we check our answers to see if this is a solution that works for both equations. Okay, so again, reminding ourselves the x values are negative 1 and the y values are 3. Here, x is a negative 1. Negative 1 equals negative 2 times y, which is a 3, plus 5. Leaving us with negative 1 equals negative 2 times 3, which is negative 6, plus 5. Negative 1 equals, here, negative 6 plus 5 is negative 1, so it works for the first equation. But let's see if it works for the second one. Here we have 2 times x. X is a 3, plus 3 times y. Oops, I made a mistake, so let's fix that. It's actually 2 times x. X is a negative 1, plus 3 times y, which is a 3, is supposed to equal 7. So here we have 2 times negative 1, which is negative 2. Here, 3 times 3 is 9, so that's plus 9 equals 7. Negative 2 plus 9 is 7. Does 7 equal 7? Yes. So here I could confidently say that the solution is indeed negative 1 comma 3 because both equations work. Okay, so that is going to conclude our lesson for today. And like always, thank you so much for tuning in. And until next time, bye.